Hello, friends. This is Mr. Roebuck again, here to talk to you about the second part of the Exploring Independence activity. I hope that you enjoyed the first part and that was helpful for you. We're now looking at a bag of marbles. So imagine you have a bag with one green marble, one blue marble, one red marble, one yellow marble. You're going to pick one marble out of the bag. What's the probability that the marble you pick is blue? Well, to think about that, I got to count up how many total options there are. Green, blue, red, yellow, that's 4. I want the probability that I pick the blue one. So my probability is going to be 1 out of 4, or 1/4. You could also do that as a fraction, or excuse me, as a decimal or percent. So say it's 0 and 2500ths, like that, or 25%. They're all equivalent. What's the probability that the marble you pick is green? It's going to be the same. So we'll just copy paste that answer down here. What's the probability that I pick a blue marble or a green marble? So if it's an or situation, I can just think about all of my possibilities. I have green, oops, here we go. I have green, blue, red, yellow. I want to know what's the probability I pick blue or green. So that'd be 2 out of the 4 possibilities. 2 out of 4 is the same thing as 1/2. So my final probability here would be 1/2. You can use the addition rule for probability, like we learned in week 1, where you do the probability of event A, that's green, probability of event B, that's blue. So that'd be 1/4 plus 1/4, that's 1/2. And then you subtract the probability of both. And in this case, you can't pick both blue and green at the same time. So the probability of both would be 0. So you could get this answer 1/4 plus 1/4 equals 1/2 minus 0, which is equal to 1/2. So 2 different ways to tackle that problem. Now we're going to pick 2 marbles. After you pick the first marble, you're going to put it back in the bag. That's important. I'm going to underline that. We call that with replacement in probability problems, with replacement. What are all of the possible outcomes? List them here in an organized way. So we're going to make another organized list like we did in part 1. I could go green, green. I could go green, blue. Go green, red. Go green, yellow. That's if I pick green first. Second possibility is I could pick blue first, and I could go, I keep on hitting the wrong button here, sorry. I could go blue, green, blue, 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 red, blue, yellow. I could also go red first, and I could go red, green, red, blue, red, 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 yellow. And my fourth possibility would be if I pick yellow first, I go yellow, green, yellow, blue, yellow, red, yellow, yellow. So this again, this strategy is called an organized list. It's a super helpful skill or strategy when you're doing probability problems. If I count these up, I've got 4, 8, 12, 16 possibilities total. I can see them all right there. What's the probability that the first marble I pick is blue? So here I look for the ones that have blue as the first marble. It's this set right there. That is 4 out of 16, which if you simplify that fraction, 4 out of 16 is equal to 1/4. What's the probability that the second marble I pick is green? So there's this one here. That's 1, 2, 3, 4. So again, 4 out of 16, which simplifies to 1/4. What's the probability that when you pick 2 marbles, you get 1 blue and 1 green in that specific order? So blue and then green. This is the only option for that. Blue first, green second. That's 1/16. 1/16 is that probability. Again, notice 1/4, 1/4, 1/16. Are these events independent? Well, for that question, we need to ask ourselves, does the first event, what I draw on the first marble, does it change the probability for the second marble? And the key thing here is that this is with replacement. I'm putting the marble that I draw first back in the bag So is the probability of the second marble any different? The answer there is no. So these events are independent because I put the first marble back. This means the probability when I draw the second marble is not affected. Moving on to number 9. What's the probability that when I pick 2 marbles, I get 1 blue and 1 green in either order? I'm going to come back up to my organized list. This one has, no, I need 1 blue and 1 green in either order. So this is one possibility here. And then this is one possibility there. I can go blue, green, or I could go green, blue. Either order. So in that case, it's 2 out of 16. 2 out of 16 simplifies to 1/8. Last question, what's the probability that when you pick 2 marbles, you get 1 blue or 1 green? You get 1 blue or 1 green. There's a couple different ways to tackle this problem, but I think the easiest one is to go up to our organized list. So 1 blue or 1 green, this entire row, they all have at least 1 green. That works. This entire row, they all have at least 1 blue. So that works. This one has a green, this one has a blue, this one has a green, this one has a blue. And I should just clarify that when a question says, what's the probability that you get a blue or a green, implied in that is also or both. So this green blue and this blue green, that counts for that because you're getting at least a blue or a green. All right, in this case, I now count these up. I have 4, 8, 10, 12 out of 16. 12 out of 16 is equal to 3/4. So my probability that I get 1 blue or 1 green, I guess this problem should really say at least 1 blue or 1 green, because the way the problem is written, I don't know if green, green, and blue, blue would count. But we'll go with the way that normally they would write, at least 1 blue or at least 1 green. If you said only 1 blue or 1 green, you would just take those two possibilities off. Instead of getting 12 out of 16, you would get 10 out of 16. Another way to tackle this problem would be to look for this kind of as an addition rule. You get a blue or you get a green. But that really comes back to just a single draw like we did here on number 3. When you're using the addition rule, it's normally looking at a single event. What's the probability of getting one possibility or the other? Not so much when you're doing 2 different events. You could make the rule work here by doing what's the probability when you do 2 draws that you get at least 1 blue, and that would be any of these and any of those going vertically. So that'd be 4, 5, 6, 7 out of 16. And what's the probability that you get at least 1 green? That would be 4, 5, 6, 7 out of 16. And if you add them together, 7/16 plus 7/16 is 14/16. And then you would have to subtract getting both. So there are 2 ways to get both, blue, green, and green, blue. So 14/16 minus 2/16 gives you 12/16, and you're right back here to 3/4. You can see it's easier to just make an organized list in this problem. That's what I would do. Moving on to the very last page. Now we're doing the same scenario, 4 marbles, we're picking 2, but this time we're not putting it back. No replacement. And that's going to change our possibilities. So let's list our possibilities in an organized way again. I'm actually going to come up here and copy paste this list to start. I'll show you why I'm doing that. So in our scenario where we replace the marbles, we have 16 possibilities. But if you don't replace the marble, when you draw green at first, there's no longer a green marble in there. So you can't get green, green. You can just get green, blue, green, red, and green, yellow. Same thing for the second thing. If you pick blue first, there's no possibility of getting blue, blue. If you pick red first, there's no possibility of getting red, red. If you pick yellow first, there's no possibility of getting yellow because you've already gotten that marble. That means if you have no replacement, our total number of outcomes possible is not 16 anymore. It's now 12 total outcomes. The reason it's different than number 4 is because we're not replacing the first marble. If we don't replace the first marble, we are not able to draw doubles. So there are 4 fewer possibilities. Now we have some questions. What's the probability that when we pick 2 marbles, we get 1 blue and 1 green in that order? Blue, green in that order. It's just this one possibility here. But this time, it's not one possibility out of 16, it's one possibility out of 12. So it's 1/12. Comparing that back to our answer in number 12, excuse me, back to that answer in number 7, that was 1/16. Are they the same or different? You guys can see they're different. And the reason is because the number of total possible outcomes is different. Probabilities are different because there are only 12 possible outcomes without replacement, but there were 16 possible outcomes with replacement. Are these events independent? Well, we have to think about this. Does the first event affect the probability of the second event? The first event, to draw any color, the probability is 1/4. But then the second event, there's only 3 marbles in the bag. So then the second event's probability is 1/3, which means the probabilities have changed. So they can't be independent. The events must be dependent because the first event changes the probability of the second event. The events are dependent because without replacement, the probability of drawing a particular color on the second try is 1/3 instead of 1/4. This is actually the case anytime you do a scenario without replacement. Whenever you do without replacement, the probabilities or the events are always dependent. 2 more questions here. What's the probability that when you pick 2 marbles, you get 1 blue and 1 green in either order? So same thing as before, green, blue, and blue, green. They both count because the order doesn't matter. There's 2 of them out of 12. 2/12 is equal to 1/6. So we have 1/6 is our answer there. What's the probability that when you pick 2 marbles, you get 1 blue or 1 green? And we're going to add in the words at least 1 blue or 1 green, because I think that's what these problems normally mean. So at least 1 blue or 1 green, let's bold them. These all have at least 1 green because the first marble is green. These all have at least 1 blue because they got blue. This one has a green, this one has a blue, this one has a green, this one has a blue. So count these up. We have 3, 6, 8, 10 out of 12. And 10 out of 12 is equal to 5/6. 5/6 of the time, there's a probability of 5/6 that you will get at least 1 blue or 1 green. And I guess in this case, you can't get doubles, so we don't even need the at least. We can cross that out. You don't need the at least because you can't get more than 1 blue if you don't put it back. We really needed the at least on the previous page. All right, that is the end of this video lesson. I hope that it helped you to make sense of the activity and check over your answers. If you found this helpful, let us know. We'd love to know if these videos do help, and if they don't, we'd love to know that too. So have a good day. Looking forward to seeing you guys during our open help sessions at 1 p.m. every day on Zoom. Thanks. Bye.